Okay, good morning. I'm going to go through several pieces for this look at early childhood and math for weeks, oh my gosh, weeks 11 and 12. Can't believe that. So we are really switching gears for these final weeks of class and narrowing down our focus to content. We've done a little bit of that with science and literacy alongside of our textbook readings. And now we are just going to focus on these content areas for the remainder of the semester. So I will be asking you to listen to these recordings because I'm not going to have you do a lot of heavy reading about this. I would prefer to give you some resources and ideas to think about in terms of how you would create a math, quote, lesson plan. And again, always keeping in mind that separating this out in early childhood is really sort of a disregard of the way the brain actually works in early childhood, but it is the way things are done currently in many spaces. By the way, not all spaces do this. And if you're interested in working in a school that's really early childhood friendly, let me know, because they exist and they're really wonderful to work in. So just let me know. For now, I am going to divide it out with the thought that, practically speaking, you will be asked to demonstrate that you're doing things to support this development. The good news is that you could do nothing for many centuries and children still developed math and science and literacy and all other skills. So just rest assured that the main thing you need to do is just shower these children with love and really rich sensory experiences. So also, you need to shower these children with your own relationship to each of the content areas, your own understanding of what they actually are and what they really mean as you grow up. That's really important to understand, because when you get to the end game in math and scientific thought, for example, you're really talking about the history of human beings trying to understand and organize and make sense of the world. So with that in mind, I'm going to take you through, this is actually a training PowerPoint for me that I use in schools with teachers of children of all ages, actually, to help you think about not math and science as fields of study, which of course they are, but what about mathematic and scientific thought? How does that work? How does it function in human beings? Because it's a huge part of actually early human beings and indigenous peoples' relationship to organizing the world. So I know you've already heard, for example, Robin Kibberer talk about the indigenous relationship to thinking about the strawberry story. I love that so much. But thinking about the reverence with which human beings at that time looked upon the math and sciences. It was not something that was mundane, pencil on paper problem solving. It was real life, the real world all around them. So this is perfect for early childhood, actually. So hopefully this little PowerPoint will inspire you, and you should go ahead and get either paper and pen that you're going to write with, or if you're going to type, just open up a Word document and you can type your responses in. And then I am going to have you do something with scissors and yarn and some other items. So you can always pause the recording when you go to do those activities. Okay, so let's go. So here is a really wonderful quote that I love that says, a wonderful exhilaration comes from holding in the mind the deepest questions we can ask. Such questions animate all scientists, therefore all children, right? Many students of science were first attracted to the field as children by popular accounts of important unsolved problems. So again, this relationship to valuing unanswered questions, unsolved problems. This is the fire that keeps us pursuing answers, which we need right now more than ever. And I love this part. They have been waiting ever since to begin working on a mystery. So just take that in for a minute and maybe write down 3 or 4 things that as a child you were curious about or saw as a mystery, even if you've since been told the answer. Just go ahead and write that down. So you can pause this while you do that if you need to. I then here have a discussion. Usually I would have teachers in group that they could talk about these mysteries. So the question I have for you up here is, in your group, you won't be in a group. If you want to do this in a group, by the way, please do. If you are in class together or you want to do this online together, if you can get an online situation, you can just take notes as you go and talk about these things together. I would love that so much. I really wish we were in person so we could do this. If you have a child at home, you can include them if you want to. That's fine with me. So when you're observing children talking about or pursuing these questions, that as the quote just mentioned, what attempts at solving it do you observe in them? And how do you feel as a teacher about letting young children pursue these and let them explore them versus answering them and explaining everything to them? What is developmentally appropriate? So how do you know when it's better to let children wonder about things and not just jump in and explain, oh, that's this, right? Like, just think about that and, jot down a few thoughts you have about it. If you're together, you can talk about it and just tell me, what you talked about. Number 2, today we're going to pursue that mystery. Share one mystery you had as a child. So I've already had you do that. Here's the one I had. I thought the ocean was under my bed at night, and I pored over a book that had pictures from the ocean in it. I was very curious about mermaids and the octopus in the book, okay? Imagine my delight as an adult when the film on Netflix came out, My Octopus Teacher. Have a look at the trailer. Okay, so go ahead and open that up and watch the trailer. This statement in the trailer really captures the idea of a child pursuing a mystery as an adult and how the interaction with our surroundings and all sentient beings that are here with us make us more human. Share a time when doing something in the natural world allowed you to feel more human or connected as was described in the trailer. Okay, so just again, you're just jotting down or typing up answers. If you're in a group, you can share those if you would like to. Make sure you do watch the trailer because it has specific things in it that I want to give you that context for the response. Okay. I'm going to pause and let you do that and go on. So the idea is to get curious. So something I'm going to do now is show you some things that I hope will inspire your curiosity. So this is a picture. It's real. It's not something photoshopped or AI generated. It's a real thing. It's a real phenomenon. So think about right now, how do you think this happened? What do you think this is? So let the child in you take a guess. What happened to create this mystery? So just go ahead and write that down. If you need to write a long answer, you can pause this. Okay, so as an adult, you can research. Here's the answer to the mystery for adults, even more wondrous. For children, it's merely language at this point. They do not need it. We can wait till they're old enough to research and wonder, as we are now. So, what's my point here? The point is that even when we explain things to children, the logic and the cognitive ability to understand what we're talking about in the context of answering what is that, it's language. And you can give them the language if you want to. But I would suggest that it's really good to let them wonder and just keep wondering about it. You know, keep talking about it over long periods of time. And just remember that anything you explain to them is language. You can get them to say the language back to you. It's not that I mean, the brain is designed to imitate expressive language and receptive language. So you can get kids to give you those answers. Some of them, not all of them. Some of them are still able to retain the wonder and love that they feel in early childhood of themselves and how they are at that age. And they don't need all these words and language. So we all know kids like that. They really are the kids we can use as a barometer of what we should be doing. So here's the explanation for you as an adult. To me, as an adult or an older child, of course you could do this with an older child, the wonder of the explanation when you can understand it is even more amazing. So if you're a young child and you start getting used to all this language that you don't really understand, it kind of puts a damper on that, you know, cherishing, I don't know what this is. I don't know how this happened. So that's just something for you to think about. And I know some of you are in spaces where you are required to give answers. So think about how you give those answers. Maybe really reduce the number of words you use, for example. And then also say, you know, it's still great to wonder about it. You know, it just keep cherishing that part. Okay. And here's another one. How did this happen? This is real also. I love this picture so much. And I love asking kids, what happened here? You know, it's just such a great thing. I love it. And here's some other marvels. You know, how did this happen? Now, I know there's a lot of people who have religious answers to these questions. And I just want to interject and say, you know, usually if you're in a school where you can talk about spirituality, you can talk about belief systems and what people believe. There are many creation myths out there, and they're worth teaching. In a Waldorf school, for example, you teach all of the creation mythologies, all of them. Children grow up learning all the different ways people throughout time have explained a sunflower, a rose, you know, certain animal species, all of that. And all of these pictures here depict something in nature that represents a mathematic concept or idea, right? You can see these spirals in each of these pictures. So a spiral is one of the, you know, more common geometric symbols that you see in the natural world. And what we're doing is teaching math spirals. We're having kids, you know, do geometry, and they haven't had as much experience in the natural world to discover those themselves. So that's a disconnect for them. if we have introduced the math shape before they've seen it and felt it in the natural world, it's a disconnect. The way human beings began to organize shapes and come up with the idea of geometry that eventually became what we call geometry was they experienced great wonder at the natural world and tried to organize their thinking around it as to what it was. So I would like for you to just remember maybe one shape you saw in nature as a child. And if you can't, which is heartbreaking, not that you can't remember it, but that you didn't have it. If you just can't remember it, that's different. But if you didn't have that experience, start thinking about how we could make sure children do have these experiences. So just jot down any ideas you have about these shapes in the natural world. And here's a really great quote I love from my favorite book when I was teaching algebra in middle school. We have found that a critical element in teachers informing their teaching with a greater understanding of learning has been their willingness to explore their own thinking. So that's pretty much what I'm asking you to do here. So on we go. So for discussion, what is your personal response to mathematical and scientific thought? How was it taught to you? Did you have experiences, textbooks, experiments, tests? Did you know any? I know I've already asked you about scientists, so let's just focus on math in this particular assignment. Did you know people who were mathematicians? Did you know that you could become one? How did you see math? How did you feel about math? And how do you feel as a preschool educator about math in your setting? What does it feel like to you? Is it just counting and it's pretty rote? It doesn't have any magic or wonder in it like we've been talking about? Okay, so go ahead and jot down those answers. So here is a little kind of a step-by-step about mathematical and scientific thought. Think about how the history of math and science. What do you know about it? In early childhood, the brain is essentially reproducing the process over a short period. So basically, in early childhood, the brain is repeating what people used to do before they knew what we know, so to speak, right? Historically, human beings were exploring, wondering, capturing the idea that there were mysteries, and then trying to problem solve them. So if you read the history of math, you can see that young children are basically doing that. They are recreating this process of organizing and coming to some kind of understanding of the world. And if we introduce the answers, so to speak, too soon, we are essentially halting that process of how to research, how to investigate, how to spend long periods of time being comfortable with not knowing an answer. Think about that. I'm going to say that again. Being comfortable with long periods of time of not knowing an answer. Being willing to pursue that answer over time, to keep trying even when it seems like you're, quote, failing, so to speak. So think about those qualities of thought in a human being and what we're doing to those qualities when we introduce the, quote, answers too soon. That's pretty much what I really want to emphasize here. Keep thinking about what we're doing with young children around the idea that there is a right answer, first of all, number one. And number two, living with what we know is a wrong answer for a long time is okay. So in this regard, I would tell you many stories, many stories of children I've taught over long periods of time who have held on to a question or a mystery for a very long time and continued to pursue the answer. The most recent example I could give of this to you is my grandson, who's 8, began cooking with me when he was when he was a baby. And, I've got pictures of him covered in flour sitting on the table with a big mixing bowl while I'm making something. His brother's making something, but he's just stirring up flour. And then, fast forward, he's age 8 and he has his own baking business where he bakes something and then we donate it to people in homeless shelters. But the point of the story is that he has gone through several stages of inquiry about that. For 8 years, he's been pursuing this idea of what a recipe is. He used to make things and throw everything in there, and then we had to taste it. And then it went from that to him realizing around the kindergarten that, there's something called a recipe where you can predict what something's going to taste like. He would start asking me, how did you make those cookies, Grandma? Because he knew I had a recipe. He would see my recipe cards, right? And he got interested in my recipe cards in first grade, when he could read. So, you just wait that time period. Now he's reading the recipe cards and going, huh. And he said, how did this person figure out what to put in there? And I said, they figured it out the same way you have figured things out. For all these years, you've been putting things together to see what happens when you do it. Does it taste good? Does it turn into anything? When Grandma bakes it, does it actually bake, or does it just stay the same? And if it doesn't bake into something, why not? And now you figured out certain things in your recipes, and this person figured out certain things in their recipes. So he's figured a lot out, actually. It's very interesting. And why has that happened? Well, number one, he had the privilege of being in a home where we could afford to let him experiment. And I want to emphasize that I'm aware of that. Not every home is going to have that. However, every home does have like spices that you're going to throw out, usually. If you're super, super, super unable to provide anything, then that's something else entirely. If you're living in the outdoors, you're just throwing together sticks and leaves and stuff like that. It's the same process. So, considering cultures who might feel that I was letting him, quote, waste food by letting him use my, expired ingredients to do his baking. I get that. I respect that. And I wonder about it myself. I just want to interject that. So be thinking about all of those things. If you object to that type of thing, you could just use natural materials. Leaves are going to expire. So, allowing children to experiment and wonder for long periods of time is the point. Could I have told him long before that, hey, there's a recipe for cookies. You don't need to make one up, right? Yeah, of course I could, but I didn't. I let him watch me cook and wonder about it, right? How does she make these cookies? They seem to taste the same way every time, unlike mine, which never tastes the same way twice. So this is a wonderful thing to let children do. It's an example of what you can do at home. I would never have been able to do that in a classroom because I wouldn't have had that much, in my classroom to let kids experiment with. But there are other things you could do that with. So just keep that in mind. Let's try a few things. Okay, so you've listened to me talk long enough. Sorry about that. So what you're going to need for this is scissors, paper, and something to write with, and string, yarn, something that you can cut into pieces. So you're going to need a long piece. All right? Okay. So this is from Fostering Algebraic Thought. So I've done this with lots of kids over the years. And I've actually done it with a lot of young kids. So keep that in mind. Of course, I'm not teaching them out. I'm teaching them algebraic thought by giving them an experience. I'm not teaching. We're always teaching algebra, by the way. But we're not calling it that. We're not saying, But if you have a parent who's bugging you, or a principal or a director, you can say, look at this. This is algebraic thought. So there you go. So you're going to take this piece of string, and it's you want it to be about 2 feet long, and you're bending the string back and forth so it looks like this. That's basically an S, I guess most people would say. The string is still in one piece, and it has 3 layers. 1, 2, 3. I've got arrows pointing to them. Okay. Then you're going to see these dotted lines that go down the middle? You're going to cut on those 2 places. So you're going to cut at the top, and then in the middle, and then at the bottom. So you could draw those dotted lines and then place the yarn on top of it and then cut, or if you're able to kind of eyeball it, you can do it that way. So what happens when you do that? Okay, you can just jot down your answer. If you want to take screenshots of what you did, then you don't have to jot anything down. You can just send me the screenshots in whatever you're submitting. If it's a Word document, just insert the screenshots into your Word document. If you're writing this up, you can just attach the photos to your submission. That's fine. When you attach photos of your notes, you can also attach photos of this. Okay. Now, what would happen if you did the same thing, but you had more layers of string folded? Okay. So what you do with older children's is you start organizing the information in a chart. You don't need to do this, but you can see, depending on the layers of string over here and the number of cuts you make, how many pieces of string does it produce, right? So this descriptive language about what we do is appropriate. This is how you do formative assessments in your lesson plans, okay? The language about these conclusions is not important, right? That comes later, as I said before. But having the experience of experimenting and laying foundation for conclusions will be important for later years. So if you are the documenter of their experience, right? They're seeing you evaluate what's happening. Wow. When you did 3 layers of string and you did no cuts, you had 1 piece of string, and so on. You see? So basically what you're doing is letting them have an experience, and then you're telling the story of that experience. So math becomes, in their minds, the story of an experience. What is the math story in this experience with the string? Okay? All right, so let's go on to another one. The star in each of us. All right, so you'll need some more string and yarn, quite a bit of it actually. If you don't have any and you can't get any, it's okay for you to just kind of guesstimate this, but if you can grab some, it would be great. And you will need partners for this if you can get them. And by the way, if you have children, they make perfect partners because you can do this with them. It's a great thing to do with them, actually. So if you want to do this in your classroom, you could, and just report back to me. You can take photos of what you do, again, and submit them, and just make sure you take a picture of the child from the back or without their head in it if they're facing forward. I don't want pictures of children's faces for privacy reasons. I'm sure you know that. Okay, so now one partner is going to stand, one will sit, and one will wrap the yarn or string to create the star drawing. One will hold the tip of the star drawing with the yarn on the head. All right, so here's how you sit or stand in star pose. So if you have somebody who can't stand in that pose, they can sit. Even somebody in a wheelchair, if they don't have use of their arms and legs, someone can hold them. You can still do this. You just make it work, as we do as early childhood educators. Here's a little video that is me doing the best I can to show you how to do this. So if you can ignore this workshop submission thing. If you want to send me pictures, you can. I would love to see that. If you want to do it with kids, you can do it with kids. You can, however you want to get it done is great. If you can't find another human being, just do it on the floor. Like make a star out of string on the floor and pretend like it's a person. Just so you have the experience. And here's more stars, right? For this, you're going to need a piece of paper, something to write with, some acorns, buttons, stones, some small object for placement on the paper. Okay, something where you can pick it up easily and that you have a lot of. Really anything, beans, pennies, and anything like that. Okay, so I'm going to have you watch these videos. Do not email me here for credit for the training. Just read over these directions. You'll have the PowerPoint in Blackboard, so you can do that. And one of the things that I do with young children with these is have them draw with their finger first, walk it on the ground first. So you put the items down on the ground and they walk the star points. So any of those things you can just do for fun. This doesn't have to, this is not usually something you would try to do with young children, although I have had teachers who tell me, oh no, my kids, once we did that star, and I said there's ways to make more points in a star, they wanted to know what that was going to look like. And then what you find with young children, of course, is they start making their own things. They'll start using the yarn to do all kinds of things. Let them. That's math. That's mathematical thought. So, and it's creating a mystery that they can pursue. So no worries about that. If you have kids who say, I want to do a 7-point star, or I want to do this number of point star, then you can say, well, how would you do that? How would you make that? So, you can let it just go like that. If you want to do more with it, here's 2 more videos for how to do that. So here's your explanation of, the I do process, right? So if you think about these stars that they're making out of yarn and you're putting things down and then they're drawing them, right? Or walking them or, painting them, whatever you decide to do with it. Just submit one picture of one you tried, so no worries there. But what I want you to get from this is this I do process. I do things. I do things and I notice what happens to them when I do them, okay? This is the process that the early childhood brain is going through. Notice the first one, I do things. No thinking about them, right? Just take that in for a moment. I do things and I notice that something happens when I do them. Okay. The next thing the brain does is I do things and I notice other things happen when I do them. Not the same thing doesn't happen all the time, maybe. Think about my grandson's process of learning to cook with a recipe or create a recipe. I do things so I can engage with what will happen when I do them. So now I'm not just doing things and going, I did that and that happened, right? Now I did that and something else happened. Think about what young children and notice that they're not yet doing things on purpose, but at some point they will. I do things so I can engage with what will happen when I do them. So now I'm realizing when I do things, things happen. Now I'm going to be more purposeful about what I do because I do want to engage with that again, right? I do things because I know what will happen when I do them, and I want to reproduce those results. So that's another layer of this mathematical scientific thought that happens in early childhood across everything they do. And then the last one, which is much later in early childhood, I want something to happen, so I do things. That's at the tail end of early childhood. So think about that. This is the process. And I just wrote it out this way for myself many, many years ago. And I have found a lot of teachers have told me this really helps to say, where are the children in my classroom? Where are they in this? And so what am I doing that's supporting that development or disconnecting them from it, right? Am I doing things in my classroom where I'm pushing them all the way to the end, where I want something to happen, so I do things? I want to be able to do this assignment in my class, this worksheet, so I do things. But is that really what should be happening? You see? So I just want you to be with that. And then I want you to think about the children that you're around, either that you're observing in your placement or that you're teaching and working with every day. And think, maybe pick 4 or 5 of them and say, where are they in that process? If I were just to let them be, where would they be? And if you're lucky enough to be in a placement where they let children be, then you'll be able to really see this and identify it. So just jot down 4 or 5 of them. No names, please. Just, I have 1 child that's here, 2 children that are here, and so on. Just do 4 or 5 kids. That's plenty. Okay? So these are basically the foundation for these everyday experiences. We've kind of talked about that already. And in terms of math, right, the earliest definition of math was founded in science, actually. So go ahead and read through this. It's just really important that we understand that, again, children are recreating this ability to organize the world. And when children are developing number sense, they usually first develop some kind of sense of quantity. They get a sense of more and less and how many. Not, if we never count with them, they would probably just, have this sense of quantity, right? Of how, comparing how long something is to how short something else is and that type of thing. They would be looking at relationships between objects, in other words. And that would lead to the language of numbers. And that's what happened historically. So what experiences do we provide that allow them to come to those experiences and conclusions? What things are we having in our classroom? And I would suggest this is where the idea of loose parts becomes super important. That there are many different types of materials that provide this sense of comparing objects to one another, because that's where this language of math becomes important, because it tells the math story. So when you create with the yarn or you make stars and all of that, you're basically fooling around with objects and seeing what the relationships are, what forms when you do certain things. If you really love math like I do, this is a book I taught in middle school. It tells this story of geometry, which is amazing. You can get it at the library. It's a really, you could read it in probably an hour. It's a middle school book. It's not complicated at all, but it really tells the story. And I wish I could require all my students to read it, but I wouldn't do that to you at this point. I do think it's really important, though, to understand this history of math and mathematical thought. Maybe you already do, which is awesome if somebody taught that to you. So here's a little 1-minute video about quantity and number sense. So, numbers are the language of quantity, right? Basically. If you don't have materials to interact with, counting is just language. It's nothing. It means nothing, right? So it's just words. And what helps is if both things are present, right? So we need to sing, dance, move, experience things, touch things, compare things. And that's how the language of numbers makes sense to kids. Then what comes later in numeracy, once you understand what is 1, what is 2, not just that you count 2 objects, but what in the world are there 2 of, right? How does that work? And I'm going to show you that in a little bit with a math Waldorf book that shows how that's taught, because I think it'll give you a better idea. But now you're moving on to one-to-one correspondence, basically. How many leaves did you find today? How many steps did you climb on the slide? How many jumps in the puddle? How many cups of flour? How many children are here today and need a cup for snack? So that all of one-to-one correspondence has a purpose, has a meaning, right? And also keep in mind they're still at the stage where everything's possible, and that will go on until kindergarten if we let it, don't interfere with it. 1 million leaves being in my backpack is still real. So you can know how to count, right? You can know how to count. There are 10 children, we need 10 cups for snack. And still say there are 1 million leaves in your backpack. Both of those things are true for young children at the same time, which is the magic and beauty of this period of life. So please leave it be. Okay? All right. So sorting things is another way to help kids create categories and ways of organizing. So having, yes, we have kids sort things. Usually we create the categories. We say, put everything red here, put everything blue here, and so on. Or we have them sort according to shapes or whatever. What if we put a whole bunch of different things out? Again, just different objects to compare with one another. And 3 shoe boxes. And just see what happens. And then observe. What do we think their categories are, right? What categories of organizing are they creating? I will tell you, if you just want to have joy in your classroom for yourself, do that. Because the joy comes in the wonder at, wow, I wonder. And by the way, that can go on for a long time and you never ask, right? If they're older, like 4 and 5-year-olds, they like to tell you that kind of thing. You can ask them. So, okay, so you put this in this box, this and this. What are these? Are these boxes, homes for specific families? Like, is this the family that's all objects that are from the outdoors? And these are all objects from the indoors? How did you do this? What's this about? But remember that when we create the categories, we've eliminated some really important thinking that we need them to be able to do, right? We need them to be able to create in their own mind how things are organized. So, it's really important not to always create the categories and assign the evaluation. Usually we do that because we're trying to see, do they know red? Do they know yellow? Do they know blue? Yes? Isn't that why we do it? Because otherwise, who cares? So if you're assessing, yes, that's appropriate. However, day-to-day activity in the classroom should allow children to sort their own categories that they create. Then there's how many times, how many things can I do with something, right? So numeracy can be the number of times things are said and done or made or picked up or whatever. Then you're dividing them into sorting categories, yes. And these become early experiences in operations, adding, subtracting, multiplying, and dividing. We're not calling them that yet, but we are seeing kids doing those, yes? So these are kind of these stages of how things progress mathematically in early childhood. If you give children enough experiences, then you can start creating math stories about what they're doing, right? You can make up a story about somebody going on a walk with a basket of apples and they give 2 away, right? Well, now, so if they had 10 apples and they gave 2 away, let's look in the basket and count how many are left. We're not saying we're subtracting, not in early childhood. However, we can start to introduce these processes that are mental operations. And this comes later in early childhood, not early. Okay? But I'm trying to give you an idea of how these things progress if we do them in the way that makes sense for kids. In terms of measurement, right? You have weight, size, relationships, again, between objects or people. Learning the language of measurement, heavy, light, small, large, short, and so on. Yes? Predictable rhythms of the day, cycles of the season. And by that, I do not mean calendar time. I mean, I call it look out the window time, right? Let's all look out the window. What do we see happening? That's calendar time, not sitting in the classroom and counting the days and all of that, right? Forget about calendar time. Go look out the window and say, what is happening outside? Replace the clock with what's happening next, or what happens before, what happens after, okay? So that the predictability of their day is how they internalize, okay, there's a clock to this. Later on, I'm going to learn to tell time. Right now, I just need to know these simple kinds of experiences where there's so much predictability that if you don't do it, I will holler. Birthdays, family events, community events, all shared events. Please measure time in those ways first. Those are the ways kids find meaning in the passage of time. And then more important than all of this put together is the rhythm in music and song, especially the drum. The drum is the heartbeat. It comes from our origins. All of us found our origins in the ancestry of the continent of Africa, every human being. And the heartbeat, the drum, is deep, deep, deep inside of us from the womb on and from our own ancestry on. So introducing rhythm using a simple hand drum. Boxes are drums, by the way. So please, that is a really important feature of measurement and of understanding time. Okay, patterns in relationships change over time. Clapping rhythmically, musical patterns in songs, things that repeat and are predictable, and things that are not. Growth cycles, observing those and understanding those, and noticing what's happened. Over, under, small, large, matching, not matching. All those things are important. And the language that describes them becomes math activity in the elementary grades. Again, you have to have the experiences and you add in the language, but only later do you actually, quote, do math. Yes? So if we do our work in early childhood, when you start doing math at school, so to speak, in early grades, this will be deep inside of you. You'll recognize it because you've experienced it, right? You've experienced all these things your teacher's talking about, and it will make sense, and it will you'll be successful. If you're not, then something else is going on. So please provide these math experiences versus explaining the answers. So we have already done science, so I'm going to skip the next part of this slideshow, and you don't need to do it either. What I'd like you to do is just put together a short little kind of summary of what you learned here. And then I am going to skip to, let's see, sorry about this. I want to find the right slide so that I do want to show you actually this book called A Beginner's Guide to Constructing the Universe. This is another, it's really worth getting a copy of this. You can buy it used, super cheap. It's been around forever. It's still my go-to book about math for young children. So again, another recommendation, not required. I did want to look at the idea of different places in Louisville that are related to math and science. This is especially West Louisville. Math and science has a huge following. They do work in schools. They have their own math nights and events that you can volunteer at. I volunteer at it all the time. I love it. So if you just research online West Louisville Math and Science, they're in town here, and they do amazing work in the realm of math. One of the things that I love about them is they do help us understand some of the racial socialization that happens in math and science, and they have instruction in how to teach math from an Afrocentric point of view. Many of you may not realize that the number system and the way we view numbers is very Eurocentric. But there are other indigenous and Afrocentric ways of looking at math that are completely different. So I would recommend that you look into those and bring those into your early childhood classroom. Bridge Kids International is another organization that, this is my friend Gerald here doing science. He's a chemist. He can come to early childhood classrooms, and he's amazing, by the way. So if you just Google Gerald Smith or contact Bridge Kids International, you can get him to come to your school. He's amazing. He does real stuff with kids. He doesn't give them a lecture on chemistry. And you can also learn more about Afrocentric math and the teaching of that from a group here in town called Play Cousins. They're now called Play Cousins Play Collective. They're everywhere. And again, they can come and do trainings, and I do use them for trainings. They're amazing. So be aware of that. And this was a part of the science, about an organization called Outdoor Afro, some books about scientists that we've already kind of talked about that in the science, and consider who visits your classroom. Something you can do when you have visitors is just ask them, tell the kids how you use math in your job. There you go. There's a reason for doing math that kids may not understand completely yet, but it's great for them to hear that. So that wraps it up. If you could make some comments about the different things I've talked about here, any questions you have, this will be your big activity for the week. And you can just turn in, again, photographs, your notes, typed up. However you want to turn in your responses is perfectly fine with me. And then at the end, if you can kind of summarize you can do a bullet point list if you want. Here's what I got from this. And think about how you might have changed some of your thinking around it. Some questions you might have about it. Anything like that, because we'll have math next week also. And I can address the answers to your questions in our work for next week. You can also start thinking about your lesson plan, because I'll be looking for this in your lesson plan as well.